Welcome to the last unit for college algebra. In Unit 5, we'll study systems. In Section 5.1, we'll examine linear systems, and in Section 5.2, we'll examine nonlinear systems. So let's get started with linear systems. We'll begin with an overview of what exactly a linear system is. So here's the definition. A linear system is a collection of two or more linear equations. The solution to a linear system in two variables is an ordered pair, xy, that satisfies both equations simultaneously. So remember, when we graph a linear equation, it turns out to be a straight line. And every single point on that line, described by an ordered pair, balances its equation. So what about a system? What is the solution to the system? The solution is the ordered pair xy that satisfies both equations simultaneously. So graphically, the solution to a linear system in two variables is the intersection point of the two lines. So to solve a system means to find the ordered pair that satisfies both equations, or graphically to find the intersection point of the two lines. Now, there's three possible orientations for two lines, and this gives us three different types of systems. The first one that we look at on the left here has two intersecting lines. Because those two lines share one point in common, we say that there's one unique solution to that system. This is what we call a consistent system. And for most of our purposes, we'll be studying consistent systems, but you want to be aware that there's other orientations possible. The two lines, L1 and L2, could possibly be parallel. If they're parallel, then they never intersect. Even though each individual line has an infinite number of ordered pairs that would balance each individual equation, the two equations don't share a single ordered pair in common. So we say there's no solution to this system. This is therefore called an inconsistent system. And the last possibility, which is a little bit unexpected, is that you have two different looking equations that actually describe the same line. The two equations generally are scalar multiples of each other. So if you have two different equations that describe the same line, then every possible ordered pair on that line will satisfy both equations. So we say that system has infinitely many solutions, and this is called a dependent system. Again, one equation depends on the other by a multiple. So three possible orientations for linear systems exist, and again, for the most part, we'll be studying consistent systems. In the next few videos, we'll look at algebraic methods for solving linear systems.